parametric equations. And this is how I want you to think about it. I gotta take you old school. I'm talking about the Etch-a-Sketch. Yeah, you saw Toy Story. You know what it is. Get up in here. All right. So, one of the functions controls up and down. The other one of the functions controls left and right. So, when I do both of them together, it can make a curve. I'm not real good at Etch-a-Sketch. Let's talk about this next stuff. Alright, we're back. What do we have? We have two functions and they're governed by the same parameter t. That's these guys. I have a function for x. It's controlled by the square of t. I have a function for y. It's controlled by the cube of t minus 4 times t. Now we see that our t is going to be in between minus 3 and 3. Ooh, so what I want to do is I want to plot a picture of those parametrics using points. And here's my points here. I went ahead and I did this ahead of time, but let me be clear on how I got these numbers here. If I'm looking at this x, if I'm looking at that x, what am I doing? I'm saying let t be a minus 3, and when we let t equal a minus 3, I'm gonna go and I'm gonna put that up in there. So then x is equal to a minus 3 squared, which is gonna get me 9. Fine. And that's how I got that 9 there. That's also how I got that 4 there, that 1 there, that none there, that 1 there, that 4 there, and that 9 there. If any of those aren't right, check me on that and post it in the comments below. Now let's look and see how we got that y right there. Oh, but let's do it for that time value. T is minus 3. Well, at least our parameter is gonna be. Here in t, I'm just saying time. It doesn't have to be time. Bam, right there. Y is equal to t to the third minus 4t. What happens when t is equal to a minus 3? Then we plug that up in there, and that's a minus 3 to the third minus 4 times a minus 3. So then we say this is 9. Fine. Minus and minus make mas. Wait for it. That's not a 9. That's a 27. Negative 27, because minus 3 times minus 3 times minus 3 is minus 27. Minus and minus make mas 12. And the difference is a minus 15. Now that's my y value, a minus 15. Now, what's going on here? By allowing this parameter to increase from our minus 3 to our positive 3, we see that our x's and y's are changing respectively with those two guys. And what's happened? We've created a collection of points. Which point? This point. That'd be my first point when t is minus 3. That'd be my second point when t is minus 2. And we continue on down that list and we do all that, and then we're gonna go and we're gonna plot those guys so that we can get an idea about how this graph looks. So I'm over here. What am I graphing? I'm graphing those guys. And here we go. My first point when t is, can you see? You can see that my t is minus 3, then my x is going to be 9, fine, and my y values are minus 15. Oh, do I have minus 15? 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, need more. 10, 11, 12, 13, 14, 15, and then that's that point right there. When t is equal to, I'm kind of hiding it, huh? Yeah, get on over in here. When t is equal to a minus 3. Yeah, you see. Alright, when t is a minus 2, t minus 2, x is 4, sure, 4, and nothing. Oh boy, really? I don't know if this is working out quite right. Anyway, I'm going to keep on keeping on. That's a 1 and a 3. A 1 and a 3 is right about there. And then a 0, 0. Whoa, what's going on with this graph? And then a 1 and a minus 3. A 1 and a minus 3. What? And then a 4 and a 0 right back there. Wow. And then a 9 and a positive 15, a 9 and a positive 15. So now, wait, were you able to see that? I'm gonna go on over here. Now we're having this parametric equation, and when we do that, we impose an order on it. So it's going in this order. It's all, whoop. 9 minus 15. All right, how do we get that? Okay, and then 4. Oh boy, that's what happened. And we'll do it in yellow. Come hit, yeah. Boom, bam. Oh, whoa. Whoa there. Now, when we do these guys, we need to put an arrow on the orientation. Because our graph is going this way, it has direction. It was like whoop-de-whoop, and I'm like whoop-de-whoop, and, you know, yeah, that's all I got.